Welcome back, guys, to the very last video in this proof of concept application for per pixel collision detection. What Logan's going to do, now that we've got our rectangle normalized against our two sprites and we're sampling the correct part of the textures, well, the final thing is just to walk through the pixels and see if we have a collision. So, Logan, take it away.
All right. So we're going to go back to the actor class, and we're going to look at what I'm going to call the check collision method. That is the method that is going to be responsible for extracting the pixel data from each texture and then comparing those arrays pixel by pixel or element by element to see if they have alpha values indicating opaque pixels. And before I get anywhere near that method, I'm going to first define a constant, which I'm going to call the alpha threshold. So you just have a tiny, tiny bit of good programming practice throughout this whole demo application. But we'll make a constant integer, which I'm going to call alpha threshold. And we can set that to a value of 48, which I think was fairly close to what we had found when we made the pixel data extraction application. That seemed to work well. Granted, I mean, we didn't do that on the versions with large images. We just had the small resized ones, but that's there for setting to whatever ends up looking good on the current textures. And now we can turn our attention to the check collision method inside of Actor. This is also going to be a static method. The way I intend this to work is it's just simply a library function, if you will, that takes in two actors and returns a boolean depending on whether or not those two are indeed colliding. So this is going to be a public static method returning a boolean called check collision. And check collision is going to need to take in two actors to look at. So we'll have an actor for actor A, and a second actor parameter called actor B. Alright, now what is the first thing that we need to do with the two actors? Well, it seems it would be wise to figure out if they are colliding or not based on the rectangle. Again, this goes back to the original description of a two-stage collision method. We're going to look at these as rectangles before we worry about pixels to avoid wasting unnecessary CPU time. So what we'll do is we'll get a collision rectangle based on both of those actors. So we'll make a rectangle variable here, much like we had done in that debug draw method out in the game class. So we'll make a rectangle called collision rect, and that is going to be equal to the result of the intersect method, where we will feed in the bounds from each actor. So that's actor A's bounds method and actor B's bounds property, not method. But that should give our collision rectangle, providing it's a valid one, or empty if it's not.
That's right.
And here's the first time we actually check that value, because if this collision rectangle is empty, we do not have a collision, and that means we want to avoid going into a per pixel level. So immediately after we get the rectangle, we'll check and see if our collision rectangle is empty, or if it is equal to rectangle.empty. If that is indeed the case, we'll simply return with a value of false from right here and not go on to consider the per pixel data. But if the rectangle is something other than empty, then we should have a valid rectangle to work with. And now we need to start describing the pixel arrays. The first thing I'm going to do is store an overall pixel count, because that'll be useful in not only building the arrays, but it'll be reused a few times afterwards. So I'm going to make an integer called pixel count. And pixel count needs to be equal to the dimensions of that collision rectangle, because the dimensions will show us exactly how many pixels, the whole width times height thing.
Exactly.
So pixel count is going to be equal to collision rectangle dot width times collision rectangle times height. Or, yes, that's right. Dot height, not times height. Now with that pixel count information, that tells us how many, well, first it tells us how many elements we need our color arrays to be. So that means if we make a color array, we can call the first of these pixels A, and that will be, we'll go ahead and initialize that to a new color array with the number of elements being equal to pixel count. Now we need a second of these arrays, because that will work great for holding the texture or the pixels out of actor A. We need the same to be able to hold the pixels for actor B. So we'll make a variable here called pixels B. Alright, now that we have our two arrays set up and initialized, we need to get the data out of the two relevant textures from the actors and store that data in the arrays. And of course, we saw how that could be done using the texture2d getData method. So let's look at a texture which is found under actors A or B. So under actor A, we can look at its texture property and tell it to get data. Of course, we can give what type that data is going to be stored in. That is, of course, going to be color. Now, for the actual data, or for the actual parameters to the method call, we had used overload 1. We had just specified a color array before. Here we're going to need to use a slightly more advanced method. We're actually going to use overload number 3. The reason being is that we need to be able to specify a rectangle, because we've found we can find normalized rectangles based on each individual sprite, and that's the only pixel information we're worried about. As a matter of fact, we have to be able to get those rectangles because those are the only relevant pixels to this collision. So now there's a few other things that we have to specify along with the rectangle in order to use this overload, and the first is level. Level is simply referring to the bitmap level, in the case of a texture that may have been bitmapped and have several different representations at different sizes. In our case, the textures that we're loading do not have such bitmaps, so I'm going to return level 0. Now the rectangle needs to be the normalized rectangle for actor A in this case, since that's the texture that we're getting information from. So that means we need to look at the normalized version of collision rectangle for actor A. So we need to look at actor A.normalized bounds feeding in the collision rectangle. And let's see, 2 more things that need to be fed in. Well, here we finally get to the array that we wish to store the information in. And this is going to be pixels A. And then the final 2 parameters allow you to put a further constraint on how much information is returned. You're given a start index and an element count. We want to start at pixel 0 available within that rectangle and move on to all of the pixels. And this is where pixels count becomes handy here. We're telling it we're not going to further constrain it. Get all of the pixels that can possibly be gathered from that rectangle. And that finishes off the call to get data. So we can finish that off. And now copy the line. So that takes care of getting the pixel data loaded into the pixels A array. So if we copy this line now, we can do the same thing for actor B's texture. This time, of course, normalizing to actor B's position using the collision rectangle and storing information in the pixels B array. Alright, and now that we have pixel information, we can loop through that data and decide if we have any cases where 2 pixels that overlay each other are both opaque. So, set up a for loop, and let's loop through each individual pixel. So for 0 unto pixel count. And the check is going to be if pixels A element I dot alpha is greater than the alpha threshold and is pixels B.
That's identical to what I wrote up on the whiteboard.
And that's what I found so funny when you were first jotting that down, is swap out a few variables and there you have the actual code.
Only difference was I did greater than or equal to. Either way.
So either way, it just whatever works best in your case. And in this case, since it's such a fine value, it would almost be unintelligible. So, as the pixels A current element alpha greater than the threshold, and pixels B current element alpha greater than the alpha threshold. If so, then we have a collision. As a matter of fact, I don't even need to bracket this because it's quite simple. If this is the case, we do in fact have a collision, and that means we need to return true.
Since check collision does indeed return a boolean. Okay, very cool.
Now, if we make it to the end of the loop and no colliding pixels were found, then we need to return false because there was no collision found within the pixels. And that wraps up the check collision method. I'll build briefly, just make sure that there's no simple syntax errors, and let's go back to the game and see how this can be used. So here we are back in game. We have our debug draw method. I'm going to change the behavior of this orange overlay collision rectangle. What I'm going to do is make sure that it's colorized based on the collision. We'll set it up so that a color of green will indicate no collision, while a color of red will indicate that there was a collision. So we'll drop this down the line and put together an if statement. And this if statement is going to be if actor.checkCollision between actors actor 1 and actor 2. If there is indeed a collision, and let me finish off that parenthesis. If there is in fact a collision, I would like the overall rectangle to be drawn with a green color. So I'll simply take red out of the mix here. So red, green, blow full 255, but leave it transparent so we can still see through it. Now, if there was not a collision, so we'll drop in an else, then we'll draw the same rectangle, but we'll draw it with red this time. So we'll draw it red, no green, but leave it transparent. Now we can build, we can run, and everything looks like it's working, but I believe there's very likely going to be a problem when we have an actual collision.
And there it is.
So what happened is I had just moved that sprite to where they would be colliding. We've invoked the check collision method. We've gotten all the way down to here, to the second get data call, and we get an exception that is explaining that the operation is aborted and the resource has been set on a device or after it was used in a tiling bracket. So what on earth is it trying to get at here? What this is more than likely a bug found in XNA version 2. I believe there have been some changes to XNA to make the differences between the PC drawing and Xbox 360 drawing, well, less different, more of a unified approach that it takes to drawing. And there are special considerations on the Xbox hardware. And what is happening here is this exception is trying to describe something about modifying a resource. We're not modifying data, we're getting it. So it could be something as simple as an overly broad check on anything dealing with the pixel data.
Right.
Now there is a workaround to this error. So if you get into any scenario where you're using get data and things stop working, you can look at the graphics device, and the graphics device has a textures array. Let me stop this section or this session and show what I'm talking about. If we go back to game for a moment and scroll down here to debug draw, here inside of the game class we have access to the current graphics device using the graphics device field. So if we look at our graphics device, we have a textures array. This has all the textures that are currently assigned to the graphics device, and the current workaround is to set element 0 equal to null. If that is nulled out, then whatever is causing that exception to trip will stop doing so. And we can prove that now by running, and we no longer get any exception, and instead we get a working collision. So we can spend just a moment and verify that that's working. We may need to flip the some of the logic around because we're getting the collision indication when there is no collision, and it flips over to green when there is. But I mean the collision that's working, we just need to swap the colors.
Mm-hmm.
So very briefly, let me get that taken care of first, because we're saying if we have a collision, then we draw in green.
The funny thing is, I was listening to you write that out, and I thought, that's odd that he wants it to show green when it, but okay, I'll go with it.
What happened is I'm looking at 255 and forgetting the places, the significance of where the 255 goes.
Yeah, I was almost about to suggest, don't you want it maybe just to be green unless it collides and then it turns red? But I was like, nah, it doesn't matter either way. You'll be able to tell it collided.
And then here, lo and behold, we run, like, wait a second, I want it to be green when it doesn't collide. So showing here, this was the intended effect. When we have a bounds collision, basically that comes back saying that the bounding boxes are in fact intersecting, drop into pixel mode, but the pixel mode finds that no visual pixels were colliding until we move close enough to trip, and there we see the actual visual.
Look in that upper left-hand corner very carefully right there. Tink.
So that allows interesting things like we can start to slide the sprites together before we get any actual collision.
Yeah, you
so
can go down on that top one almost.
So yeah, very highly accurate, very nice result here. So now you don't have to worry about making all of your objects circle-based or square-based. No, anything you want can be an accurate collision. Just keep in mind that this is, of course, somewhat expensive, and therefore you want to make sure your textures aren't too huge or things don't overlap too much. But, I mean, there you have it. There you have the basics. Now, before we wrap this video up, I do want to kind of clean up our workaround here. I don't want to have to always remember to set the graphics device texture sub 0 to null in order to avoid that problem. So what I'm going to do is I want to keep this along with our collision check here, because this is the only relevant place in code where we actually need to do that to the graphics device. And the problem is right here we don't have access to that property. So what I'm going to do is I'm going to add a graphics device property to the actor, a static property, and we'll use that to hold on to the graphics device. So public static graphics device, which we can call graphics device. And then we'll use that instead. So this line where we were setting graphics device texture 0 equal to null, we'll completely remove that line and instead move it to the check collision method within actor right before we get the texture data. And of course here, graphics device is just a field, so we need to make sure that we populate that field, but we can do so in a place that is unlikely to ever need to be moved. So here we can look at actor, set the graphics equal to the game's graphics device. And now making sure that this is moved out of the way, we can run. We get no error. And just to verify that that was, in fact, the line that's saving us, if we comment this line now, and we get the crash. So that makes a nice workaround for the time being, so you can get everything up and running, everything working perfectly inside of XNA 2.0.
Right, and again, if you guys happen to have downloaded a patch or an updated version and you're not having this problem, then the original way that Logan demonstrated it is perfect. It's the way it's supposed to be. And if you are having this issue, there's a workaround. And hopefully they'll have it fixed in the very near future. But bugs do seem to manage to get their way into just about every piece of software. So with that, that is going to wrap up this proof of concept application. Now, in the next part of this mini-series, we're going to begin exploring how to go about doing per-pixel collision detection on animated sprites. So be interesting. And with that, that is going to wrap up this video. Thanks a lot.